All right. Hopefully you have polyatomic ions and binary ionic down pat. You're pretty comfortable with it. You don't necessarily have to be a full-blown expert, but if you think about it and you work at it, you can do it. That's where you need to be. Okay? So now we're adding transition metals. This is the D block, groups 3 through 12. And the big thing with them is, well, who needs one charge anyway? Because they certainly don't. They like to be different. They like to have more than one possible charge. For example, iron. Iron can be 2 plus or 3 plus. And so, like I said, they're found in the D block. We also consider these heavy metals down here to be transition metals because they can also have multiple charges. Tin, lead, antimony, and bismuth. Okay, I have these three in a different color because, well, they're different. They don't have multiple charges. Nickel is always going to be 2 plus. Zinc is always going to be 2 plus, and silver is always going to be 1 plus. And so the way I remember this, see they're right here in this top corner of the D block, and they make a V. The 2 at the top are always 2 plus. The 1 on the bottom is always 1 plus. So that's how I memorize it. It makes this V right here that I can see on the periodic table, and I can color it in when, or students can color it in when they get their periodic table. And these two are always 2 plus. This one's always 1 plus. Just kind of like we did with the polyatomic ion. You can just look at it. Here's the box. So these 4 get 4. Everybody else gets 3. And then you can see the pattern. 1, 2, 3, 1, 2, 3. You can write that kind of stuff on a periodic table. You can just look at a periodic table and see it. And that's what I think is just an essential skill for not only teaching chemistry, but doing chemistry. So these two are 2 plus, 1 plus. All right. All right. Since there are more than one possible charges, we need to somehow signify what charge it has. And we do this with Roman numerals in a parentheses. So for example, the Roman numeral 2 in iron 2 shows you that it's 2 plus. And the 3 shows you that it's 3 plus. The most common mistake people do here is they try to make the Roman numeral be the quantity or the number of atoms. No. So once again, here is kind of a close rhyme. Roman numeral shows you the charge, not how many atoms there are. Okay, so it's a simple little rhyme. You say it in your head, and it keeps you from making that mistake. The Roman numeral shows you the charge, not how many atoms there are. All right, let's look at some examples. So they're written just like other formulas. We just need to use the Roman numeral to tell us what the charge is. So copper 2 sulfate, that's how you would read that. So copper 2 sulfate means that the copper is 2 plus, because the Roman numeral tells us the charge, not how many atoms there are. And the sulfate is written SO4 2 minus. Now, when you're doing your workbook, I would strongly encourage you to write it out like this. Don't just try to jump to the formula, because I think that can just make things more difficult than they need to be. So slow down and do it one step at a time until you get really, really comfortable with this. Then you can go faster. So 2 plus, so I write my positive ion, I write my negative ion, then I write my formula. Okay, 2 plus and 2 minus cancel each other out, CuSO4. Chromium 2 chloride, same thing, Cr is 2 plus. Chloride's 1 minus, do your crisscross. Okay, notice in the formula, there's no Roman numeral. The Roman numeral is only in the name. Okay, so don't make that mistake and try to do that either. But also notice the Roman numeral doesn't correspond to quantity. Okay, there's no 2's here. Okay, it's just simply about charge. There's a 2 here, but it's not on the chromium. It's over there. Okay, so don't use the Roman numerals for quantities. Get you in trouble. All right, so iron 3 oxide, better known as rust. Iron is 3 plus, oxide is 2 minus. Therefore, the formula is Fe2O3. All right, so going from name to formula for transition metals is not that tricky. You just use the Roman numeral to tell you what the charge is. And then it's pretty simple after that. Well, the problem is determining the charge, going the other way around. The key thing here is remembering that the charges are equal to each other. Just like we did when we did binary ionic. And I encourage you to try that activity where you're trying to make the charges balance each other out with the different size cards. Same thing's going on here. That the positive charge and the negative charge have to be equal. And they have to cancel each other out. So when we look at a formula like PbO, all right, lead's one of those things, and lead can be lead 2 or it can be lead 4. But we need to figure out which one it is. And so the oxygen is 2 minus. So what's the lead have to be? The lead has to be 2 plus in order to cancel it out. Okay, so it's lead 2 oxide. All right. So you got to work on that aspect of balancing out the charges. Now this takes a little practice. Well, not a little. It takes practice, and it takes getting used to. All right. So let's look at some examples. Okay. So like I said, you need to find the charge on the negative first, and then use that to find the charge on the transition metal. Okay, so the carbonate is 2 minus. So that 10 has to be 2 plus. So we would write this as 10,2 carbonate. Chloride has a 1 minus charge, but I have 3 of them. So my negative charge is 3 minus. That means my cobalt needs to be 3 plus. And therefore I get cobalt 3 chloride. And then same thing for iron. I've got 3 sulfurs, 2 minus each, for a total of 6. So I need to get 6 plus for my iron, but I have 2 of them. So each iron is 3 plus. That gives me iron 3 sulfide. Okay, you may notice you can also kind of do a kind of almost reverse crisscross, that the 3 becomes the charge on the iron, the 2 is the charge on the sulfur. It works if the non-metal part lines up. So like 1 matches the charge on chloride, so the 3 is going to be the charge on the cobalt. But if we look here, there's only 1 carbonate and 1 tin. So if I do 1 up here, 1's not the charge on carbonate. That doesn't work. So you have to think it this way through. All right, so just kind of, you can do reverse crisscross, but it doesn't always work. You should always double check your answers by looking at whether or not the charges all work out. So that's transition metals. They're not super tricky. I think polyatomic ions are a little bit trickier, but this is the tricky part, figuring out what the Roman numeral is. Okay, and so think of trying to balance out those charges, and that'll get you where you need to be in terms of the Roman numeral. All right, the final lesson in this unit is we're going to take covalent and ionic nomenclature and put them all together. We're going to do what I call cumulative nomenclature review. Okay, so we're going to put all of these things together. So hopefully you've got binary ionic down, polyatomic ions down, and you've got these transition metals. Go to the workbook, practice it, get it down before you move into the final and last lesson.